Hi, I'm Bogdan. The first thing you notice that I'm speaking English. There is such a movement among meetups, including Kiev, and at least me and I and Ivan Daniluk share this vision that in order to promote our meetups throughout the world, we'd better speak in a world-recognized language. So I have this talk. I'll be speaking mostly Golang and Rust or backend in general. I have started early in working with computers. The first my experience was when I had a DOS box with x86, and that was Pascal, eventually assembler, and I even wrote my first terminated state resident program. So backend and mostly Golang. I will start with Golang. You probably know already a lot, and I found the slide from the presentation when Golang was introduced to the public. That was in 2009 on October 30th, and this was almost 10 years ago. And from this, I would highlight type safety, memory safety, and high-speed compilation. By the way, you notice that if you will later need to access the slide, you just write down the URL. So let's take a look at how it was.
What are the goals of this language? The sort of short version of the story is we want the efficiency of a statically compiled language, that means truly compiled language, but the ease of programming of a dynamic language. And I think we've come pretty close to achieving that.
If we scroll a bit, there'll be a demo of compilation.
This is a directory of Go code. If you look in here, there's about 1,300 lines. So I'll make clean, and then I'll just do make here. There, I just built the math library. That's compiled, sufficient code, clean again. In case you wonder if I can type. Okay, time make. Okay, so that's about pretty accurate. 200
There was 200 milliseconds compiling the code. This was 2009, and back at that time, Google had mostly Python, Java, and C++ code, at least as far as I know that. And C++ code took quite a time to compile. I had a job in 2005, and the company used a distributed system to spread the code around a number of computers just to get a binary for your PC. And partially is that due to generics, or how they are implemented in C++. This is an example from a standard C++ library, and least to say it's not quite readable. And in C++, generics are not much checked during compilation of the generic code itself. Rather, when you substitute a type, this is when compiler can check if your code makes sense. Because prior to that, it has little knowledge. And Golang, at least with such reason, gave up on using generics generally. It does have generic like map and arrays, but otherwise it's not. And you can check out the original post by Russ Cox, who had had a lot of discussion around what are the advantages and what do we pay for having generics. And on this, and as I'm approaching to selling you Golang, if you happen not to use it, I have a demo. The demo is on GitHub, and when you come home, you can open it and play with it. But let me show it. I actually have two computers specifically for this presentation. There's two medium instances in Amazon. One of them is accepting a connection. If you post to this server, it will accept a connection and hold it until you issue a delete request somewhere. And the client only sends a number of connections to, and this way you simply establish a number of connections between the client and the server. So let's and let's go slate. So here is a client, and well, the server is there, and it wrote the connection number, and let's terminate all this. And it's done. So the reason of this demo, or why I wrote it, is the simplicity of the server, and it has 78 lines total. This contains most of the logic. Like I take a connection and I wait till something happens. And in simplicity, I also, this is made possible by the Go runtime, because Go runtime has coroutines, and when you write the simple line, which is basically read something from the channel, the coroutine gets set to the queue of coroutines that await execution from somewhere. So if you may probably say that you can write this in Python, C#, Java, or Ruby, and I encourage you to do that and send me the code. Or I'd like to compare how hard it is to create equivalently powerful and easy to write program. But Go doesn't run just fair, but there is a price to pay for this. I have another demo where where mostly where the handler does something compute intensive. In this case, it calculates n in the power of 3, and this is something just to warm up CPU. It doesn't have any specific meaning apart from that. And the point is to send as much requests as possible and see what happens. If I run one, that takes around 300 milliseconds to compute. But if you, by the way, there is also a way to check status of this. But if we make it, if we run around 100 requests that that take the CPU time, you will notice that the server starts accepting these connections, but doing almost nothing in compute. And if you request for status, just simple call to answer with one string. Just if will wait for CPU when the coroutines are taking the CPU. This is possible to overcome, I believe, with when you create an explicit pool of coroutines that process CPU-intensive tasks, and you lock CPU threads for it, and you assign a lower priority than the other CPU thread for other coroutines will be able to reply to this status. But so far, you may see that it takes up to 9 seconds in this case for the Go scheduling system to go through the coroutines and give time to that coroutine. I did encounter a few gotchas. First, I did write a coroutine leak, but I just sent a link to the document that better studies the subject. I am guilty of taking a slice from the buffer and putting that slice into a map. So this code has a problem. Maybe what's your idea what's wrong with it? There's no ray condition. But in my case, the buffer was around 4 kilobytes, and as I found out what the meaningful part of it and placed into the map, the usage of the memory is 4 kilobytes. So I pinned the whole buffer. I also did this, and the first part is when you check for error and exit. And it happens so that in the reading interface, it can return a number of processed bytes and errors. So when you read, you should check for processed bytes first and error second. I also, but rather long time ago, I returned my error type from the function, and a typical, this is even a place for bugs, is calculating length of the string. And to demonstrate this, there is a simple program that probably doesn't give what you want to do. It gives you the number of bytes taken by the string. But this is gorgeous, and you probably know it. Now, roughly at the same time when Golang was exposed to public, there was a language Rust made by Mozilla, because almost for the same background. The developers of Mozilla were fed up with C++, but for different reasons. And to speak about that reasons, I need to speak about bugs. And there are obviously bugs you just happen to write when you develop, then you run it and you notice it. There are bugs that you happen to send for code review, but then they get noticed, and well, they are fixed during the code review. There are sadly worse bugs that go to production and then can end up in unpleasant talks. Worst, that bugs may not be deterministic, but happen time to time. Like some percentages of users report it happened, but well, as you check it, they're gone. And but clearly it must be somewhere. And ultimately, there is a price of a bug. For some companies like the Jane Street, which is in London, which is a trading company, and one of the developers says that there is no worse bug when you introduce some minor flaw that costs you money, and you run it 1,000,000 times per second, and then, well, bam, and your company is burned. So that type of bugs are very unwanted. And this was the reason why Mozilla has created bugs, Rust. I have a few screenshots. As I get prepared, I have a few screenshots back from 2017. This is a list of security vulnerabilities, and one of them was guilty of buffer overflow. This is guilty to integer overflow. So okay, it's not exactly this. Then I have a firmware Asus router, and it constantly saying me that what time from time that this is in your firmware update available, and in the recent firmware there was a integer underflow error. So let's go faster through this. Fixed remote code execution vulnerability, for example, and on stack-based overflow. So this is a kind of errors you may want to avoid, and to do that you want to use a different technology, or have something to help you. And what Rust did is a simple thing that of the change in language. They first tried to fix C++, but they gave up and wrote their own. So this is a simple program. It just puts a screen, and single variable, and if you change it, for example, like what if you enter a new variable and also name it and assign it from X? So as a spoiler, this won't compile. And the issue is that the Rust will say, hey, you borrowed a value here, but you're using it again, and thus you have two names for a single place in memory, and this is not what we want. And in fact, this makes Rust a language for a subset of algorithms. That is, not every correct algorithm can be represented in Rust, but there is a different value from this. I will show a bit later. Then the approach, as some people notice, there are macros in Rust, and unlike Go, even print itself is a macro. This little sign says that, hey, what you write is not actually code. This is something for the compiler to produce code. And if you ask the system to expand your macros, you happen to have this that you pass to compiler. So Go relies on reflections to print your values, and mostly in your backend scenario, this is fine. And and if you want to do this faster, you just introduce a method that go directly to convert something into strings. And you either want this when you do something for a million times a second, like write in JSON. In that case, in Golang, you would use fast JSON library, which will pre-generate JSON output code for you. And in Rust, you will mostly annotate your code with something that will say that, hey, I want this structure to be serializable. And this is a notation for the compiler to say that, hey, you need to generate code. This is a bit of different approach, and you mostly value that when you do embedded development. The other thing in Rust and languages like OCaml, F#, and TypeScript are algebraic data types. They're actually simple, but to deliver the idea better, I'll use a video from the Jane Street
company. And here we see in the middle of it, there's this match statement. We match X with, and if it's in order O, then we...
I'm a bit rushed. So there is this type instruction. Okay, there is an order. An order is something that has an ID, a price, and a size. And the cancel type, which only has an ID of thousand to cancel. So these are clearly different types, first to say. Then instruction is either of the two. It's either the order or either cancel. And that is this simple. And all the possible values of the instruction type is the sum of these possible values and the sum of the second possible values. Unlike this structure, where the all possible sets are multiplications of each field. And this is, by these analogies, the types are called algebraic data types. But what makes this this worth, or what makes this valuable, is that when you decompose the type back into primitives, back into components, like you have to match the incoming instance either with the order or the cancel, this is where value happens.
For which the function returned true. Right? So it's a fairly simple function, and here you'll see in the middle of it, there's this match statement. We match x with, and if it's an order O, then we check whether or not the ID field is equal to OID, and if it's a cancel C, we check if the XID is equal to OID. Now this is a really, really trivial example of a match statement. You could do much, much fancier things, but the utility of this approach shows up even when you're doing very simple things. So to see why this is useful, let's see what happens when we need to change our code. So it turns out we forgot one of the possible kinds of transactions you can have on the markets. There's another kind of transaction called a cancel replace. And a cancel replace is basically a request for the exchange to do an atomic transaction where it gets rid of one order and replaces it with essentially a new version of the order with a new price and a new size. And that's what the fields in there are meant to represent. And then we can also go and add this to our variant. So now, when we go over this list of instructions, we can include cancel replaces. So what happens now to this code? Well, what happens is the compiler notices that this code does not work. Right? It says, oh!
So at this, when you extend your algebraic data types, and in your code starts to break in the point where you forget about your extended type. And this is a feature, and this is something you want to have when you write code that with bugs that may cost you something. By the way, this is a talk about OCaml from the same company, Jane Street, and this is about functional programming. And I do recommend watching it entirely, though it's a bit old, but it's wonderful for software development. And just as a relatively simple thing is when you write a very efficient code and you stuck with 64 bits, well, Rust can save you. So this is my introduction. As in the Golang UI chat, we have talks that here and there may diminish other technologies. I came up with a talk that to show the cases where you probably want to give up some of the nice properties of Golang towards, well, different set benefits. But still, I write mostly Golang at work. I happened to be on both sides. First, I once started to write it in network encoded Rust, and they gave up and wrote in Golang. Then, this is my pet project. Another my pet project, when I dealt with, I tried to solve a game, meaning I wanted to know for some for a game known Kalaha, I wanted to figure out if the first player may always win the game. And what I started this in Go, but then gave up and wrote a bit in Rust. This is an old code, and I didn't write much by the time. So as I looked today, it's not beautiful, but this is a testament that, well, you may switch to Rust. And in here, I had an interesting observation. In the solution, I maintained a set of games that certainly lead to win for the party that has to play. And I also maintained a set of games that cannot lead to victory in any case. Meaning a perfect opponent can always make the game a draw. Now, I wanted to run this on all the CPU cores, and for this I had to give this instance and share it with many CPU workers. So and to do this, I had to wrap it in a read-write lock. But and then what happens is you don't just pass the variable. You take a read log of it and pass it into a thread. And well, to maintain the number of instances that took the read log, I had to wrap it in automatic reference counting instance. And so this one compiled and worked, and prior to this I tried to make it simpler. I just borrowing the instance into the workers, and it did not compile. It later came to realize that the minimal working example and minimal correct working example was like this. I had to maintain a log and I had to maintain a reference counter. And this is a bonus one. The compiler stopped me from possibly making a bug. Overall, this is all talk, and questions are welcome. You may have them.
Okay, so there are two languages. When you would recommend which?
So, if you write networking code, use Go. Go is a sweet spot, and this will save you many times over. And almost no technology on the market gives you such ease of writing networking code. And for this, there was this selling point of 10,000 connections. If you doubt, you may try to do this in other technologies. So this is the sweet spot. Now, if you're mostly doing compute and your domain is complicated or very responsible, right? You are writing medical program, or you are writing something for trading. In this case, go for Rust. You will have to learn much more just to make any progress in the language, but as you start, you will understand why it was created and what benefits this gives. And also, if you write an embedded system, this is also a very good case for Rust. In that, mostly due to macros and the type system, because you can write lower level primitives, like ones that deal with buttons, with lights, with whatever you have, and then write code using those primitives. But when you compile that with Rust compiler, it has the advantage of doing the substitution work for you, and this would be harder in C++.
Богдане, дякую тобі за доповідь. У мене два питання. Перше питання. Ти кажеш, що можна використовувати Rust для embedded систем, але коли я спробував його запустити, щось схоже на Hello World, бінар складав 68 мегабайт. Як можна це порівняти для embedded систем?
Я навіть запускав, я хотів показати, але для швидкості я це не показував, то разом зі стандартною бібліотекою бінар 1.6 в Go 1.9. Для бекенда це ніщо, а для embedded тобі треба, тобто, по-перше, 68 мегабайт, ти щось не так зробив або щось не то підгрузив. А друге, там використовується флажок, щоб не використовувати стандартну бібліотеку, там підтягується замість неї core, і тобі для того, щоб вивести щось на екран, треба дати свою функцію виводу на екран, там, оскільки ти embedded.
Так, дякую. Друге питання. Я так зрозумів, що в Rust потрібно дуже сильно занурюватись, це дуже схоже на функціональне програмування, і це не мейнстрім, як Гошка. От порівняй Rust з традиційними мовами там, функціонального програмування.
Якщо Гошка мейнстрім, щоб було класно, то дійсно Rust не мейнстрім, і тим більше в Києві. Його пишуть найбільше коду, напевно, в Mozilla, там переписали Firefox Quantum. Що, як контраргумент, використання Quantum не зупинило Firefox від багу, який стався на днях, але це side note. Отже, але переписують контейнер runtime, це робить Oracle, на Rust. Сходу, на сторінці Rust проєкту є такий showcase, who uses Rust. І там є багато компаній, в тому числі Google пише свій текстовий редактор He, і в них бекенд, там в текстовий редактор з двох частин, і бекенд написано на Rust. Що ще цікавого? В Dropbox більшість коду на Go, але є Magic Bucket, який займається викачкою файликів за якимсь там ID або хеш-сумою, і він був запущений 5 років тому на машинах з 96 гігабайтами оперативної пам'яті, і в Magic Bucket вони написали на Rust.
А як справи з корутинами в Rust? Вони вже завезли на рівні мови, чи досі треба підключати якісь сторонні ліби?
Ні, не завезли. Там навіть є сайт areweasyncyet.rs, типу, чи завезена, йде мова про async await, щоб писати цю стейт-машину, яка очікує, щоб вигружати очікування на подію в окрему чергу, async await, то який є в інших мовах, а це ще не завезли. І бібліотека для того, щоб писати highly effective networking code, вона називається Tokyo або настройка дней Hyper. І там інший принцип. Там повертається в момент, коли відбувається IO, і воно без результату, там треба